This question scares a lot of people, but I think it's pretty easy because I instantly recognize what I'm dealing with. And this takes experience, obviously, but it's kind of a way to highlight the get back to basics strategy, which is a reminder that the SAT isn't asking about like every single math concept in existence. There's a set number of things that they tend to ask about, and they make the questions look different from test to test. But the concepts are basically the same. So if we can recognize what concept we're dealing with, we probably already then have a way of solving it. And so here, we're talking about a circle, and specifically we're talking about circle sectors. So in my study guides, I call these part over whole questions, and that's because I usually solve these by setting up a fraction to represent the fraction of the circle. So I'm always then looking for these two components, right? What is the part that they're asking about, and then what's the whole that kind of corresponds to that? So the weird thing here is that the part is a fraction, right? They're saying 5 pi over 4 radians, and that is the measure of the angle. So let's put a picture here. I think that might actually help us. So we have a circle, and they're telling me, this is not to scale or anything, but OB is this sector. And so we're trying to figure out some stuff about this sector. So the thing that they're giving me with this 5 pi on 4 is the measure of this angle in radians. So it's part of the circle. So when I put it in my fraction, 5 pi on 4 is part of the main fraction. It's going to be up here as the part. So yeah, we have a fraction within a fraction. It happens. Not a big deal. Okay, so this is why getting back to basics is actually really helpful, because if we trust the basic underlying formula, then it doesn't bother us when something weird happens. So it doesn't bother me that I have a fraction up here because I know that the part goes on the top, and the part is a fraction, but so it goes on the top. Doesn't matter. The issue for most people is the whole, right? What we want is a way to kind of represent the entire circle. So radians are weird. We don't have a lot of experience with them. But if, let's say, it was an angle in degrees, we would put 360 degrees, right? Because that's the whole way around the circle is 360 degrees. So if it was a 40-degree angle, then that would be the part, right? So this is not, again, it's not to scale. This is not the value. But 40 degrees is the part. The whole would be 360. With radians, the numbers are different, but the concept is the same. So the part, like we said, is 5 pi on 4. What's the whole number of radians in a circle? You might have memorized it at some point, but if you didn't, you're in luck. Go back to the beginning of the section. They tell us the number of radians of arc in a circle is 2 pi. And notice, it's right below that 360, so that's confirmation that we kind of are finding the right thing. It matches our expectations. So 2 pi then is the whole. Now, on a lot of these questions, what we end up doing is creating another fraction that we set equal to this. We basically use ratios and proportions to kind of figure out a missing piece. And so there's a lot of cross multiplying and all that stuff, but here we don't need to do that. The first clue is basically that we don't have any other information, so there's really nothing else we could kind of put in another fraction, so that kind of limits us. But the most important piece here is they're asking for what fraction of a circle this is. And the reason that part over whole works is it's a way of representing the fraction of the circle that we have. So the whole fraction is the answer. So what we need to do with what we just created is simplify it. Once we simplify it, we're done. So we need to kind of know the rules for dealing with double fractions in order to do that. The way I learned it is it's better to have two fractions, so that way we have some balance. And then we do keep, change, flip. We keep the top fraction as is, so 5 pi on 4. We change division to multiplication. And we flip the bottom fraction upside down. So keep, change, flip. Now that becomes 5 pi on 4 times 1 over 2 pi. And now it's just multiplication of fractions, the easiest thing that we can actually do with fractions. So the pi's are going to cancel out because there's a pi on the top and the pi on the bottom, so it reduces. But nothing else can reduce, so we just multiply across. So 5 times 1 is 5, 4 times 2 is 8, and that's the answer, 5/8. And so you can bubble it as a fraction, you can bubble it as a decimal, whatever you want to do, but that's it. if you practice more and you start to notice every time you get a question that's about sectors of circles, you will notice that you're kind of using the same formula again and again. Now, when I learned this in school, I learned separate formulas for every situation. I had a formula for the fraction or the area of a sector, a formula for the circumference or the arc length of a sector, a formula for the degree measure of a sector, a formula for the radians of a sector. Everything had its own formula. I hate that. That's not how math should be taught. We don't like memorizing things, so why make us memorize 4 different things when we can memorize one thing and be covered for the 4 different situations? So that's my goal with this kind of thing. And so if you look at all my videos about part over whole, you will see that the situation changes. Sometimes we're talking about area, sometimes circumference, sometimes radians, sometimes degrees, but the process stays the same. And that's because Get Back to Basics really does work. They're going to twist up the questions, they're going to make things look different, but the underlying concept is the same. So if you can recognize what the question is testing, you can get back to basics and have some sort of process ready to go to handle any type of that question that you might see. And that, means confidence on the test and a higher score.